The apparatus below consists of a porous pot containing gas X. This is a porous pot. A porous pot is a pot in which gaseous exchange can occur freely, which is then surrounded by a gas Y in a beaker. Gas Y is delivered into the beaker, which is outside the porous pot via this delivery tube. Which one of the following pairs of gases would cause an upward movement of the liquid in the right hand limb of the U tube? In other words, this is a manometer, which is also a U tube, just a glass U tube, and they want to have this side, the liquid, to rise up. For this to happen, if this side the liquid is to go up, this side the liquid would actually start to come down. So on the left hand side, the liquid level is going to go down. If the left hand side the liquid is going down, that means the pressure of the gas inside the pot X must be greater than the atmospheric pressure. The pressure inside the porous pot is greater than that of outside. Only then the extra gas molecules that is present inside the gas X would actually cause this water level to drop, because it will push on it, and this side will go up and this side will go down. Now, when would that happen? If gas Y diffuses in faster than gas X diffusing out of the pot. If gas Y goes in faster compared to the gas X coming out of the porous pot, that's when there will be extra gaseous molecules here and the pressure would increase and it will push down. Right? That's when it is going to happen. Now, for this to happen, gas Y must be less dense compared to the gas X, which is inside the porous pot. Now, how do we determine which gas is less dense or more dense? Of course, we make use of the relative molecular mass of the gases. So, we are just going to compare between gas Y and gas X. So, what we need in order for the pressure inside the buildup is gas Y must be having a lower relative molecular mass compared to gas X. That's what we need to work out. So, in this table, we can see a list of gases, given side by side. And what we're going to do is to work out the MR values for each and every one of the gases. If you go to hydrogen and we take a look at the periodic table, relative atomic mass of hydrogen is a 1 and this is a diatomic molecule. So the MR value for hydrogen is going to be 2. So for ammonia, we have 1 nitrogen attached to 3 hydrogen atoms, and that's going to have a relative molecular mass of 17. So obviously here gas X is less dense compared to gas Y. But what we need is gas Y to be less dense compared to gas X. So the numbers on the right hand side of the column must be smaller compared to the left side. That's what we are looking at. Let's simplify it that way so it's easy to see. So let's work out for ammonia, and of course we have already worked it out. It's a 17, the MR value. And for carbon dioxide, 1 carbon and 2 oxygen atom to make up the carbon dioxide. And if we use the periodic table and the relative atomic masses and we work out the MR value, it should work out to 44. So again, the gas Y happens to be denser compared to gas X. If you look at option C, oxygen gas, it's a diatomic oxygen. So it has a relative molecular mass of 32, and hydrogen has a relative molecular mass of 2. So obviously at this stage we can see gas Y is less dense compared to gas X. So this is the right option, but anyway, just let's work out the option D as well. The relative molecular mass of oxygen is 32, right, because 2 times is 16, because at the relative atomic mass of oxygen is 16. And for carbon dioxide, we can take it from here, it's also 44. So the only option in which gas Y is less dense compared to gas X is option C, and hence option C is the correct answer.